Chapter 4.2 is solving quadratic equations by factoring. Zero product property. If two factors of a quadratic equation have a product of 0, then one of those factors must be equal to 0. So if we have x plus a times x plus b equals 0, then either x plus a equals 0 or x plus b equals 0. To solve by factoring, remember to remove any common factors first. Check for special products and factor fully. Example, solve x squared plus 5x plus 6 equals 0. So obviously we are solving all of these by factoring. Factoring a trinomial. First of all, we look for a common factor, x squared plus 5x plus 6. There's no common factor. Because the leading coefficient is 1, the number in front of x squared would be a positive 1. That means this is a basic trinomial. So we want two numbers that multiply to the c value, which is 6, and add to the b value, which is positive 5. What two numbers multiply to 6 and add to 5? That would be 2 and 3. 2 and 3. Then because this is a basic trinomial, we can go right to our two factors, x plus 2 because it was a positive 2, and x plus 3 because it's a positive 3. So x plus 2 times x plus 3 equals 0. Then, if either of these factors equals 0, that's when we get a product of 0. So we want to figure out, when does this factor equal 0? Subtract 2 from both sides. We get when x equals negative 2, then x plus 2 equals 0. And do the same for this factor. When does that equal to 0? X plus 3 equals 0. Subtract 3 from both sides when x equals negative 3. So our solutions are x equals negative 2 and x equals negative 3. And let's just put a note here about the zero product property. So for x plus 2 times x plus 3 to equal 0, either x plus 2 equals 0 or x plus 3 equals 0. Solve both cases. Example, solve x squared plus 30 equals 9 plus 10x. Before we can factor, we need everything to be on one side, and ideally we want to move it to the side that would make the leading coefficient, the number in front of x squared, a positive. So on the left, I see that this is a positive 1, so I'm going to move everything to the left side. I would need to subtract 9 from both sides, and subtract 10x from both sides. Then I get x squared minus 10x. 30 minus 9 is 21, so plus 21 equals 0. Look for a common factor, x squared, negative 10x, and 21. There's no common factor. This is a basic trinomial, again, because we have a 1 in front of x squared. So find two numbers that multiply to 21 and add to negative 10. That would be negative 7, negative 3. Negative 7, negative 3. Because it's a basic trinomial, we can go from there right to our two binomials. We would get x minus 7 times x minus 3 equals 0. For this product to equal 0, one of our binomials has to equal 0. So let's figure out when this equals 0. X minus 7 equals 0. Add 7 to both sides. We get x equals 7. And when is the second factor equal to 0? X minus 3 equals 0. Add 3 to both sides. X equals 3. So our two solutions are x equals 7 and x equals 3. Those are the x-intercepts, or the solutions, or the roots, or the zeros. All different terms for the same thing. Example, solve 2t squared plus 11t plus 5 equals 0. Look for a common factor, 2, 11, and 5. There's no common factor there, so I want to factor this trinomial, but I have something other than a 1 in front of the t squared term. That makes this a complex trinomial. So we have to multiply a times c. 2 times 5 equals 10. Okay, so this is a complex trinomial. And that means we have to use the box method to factor it. So we have 2 times 5 is 10. We want two numbers that multiply to that value, so multiply to 10, and still add to the middle term, which is 11. Two numbers that multiply to 10 and add to 11 would be 10 and 1. This is where it differs again from basic trinomials. We can't go right to our binomials. We have to use the box method, so draw a box and split it into 4 sections. In the top left box, you're going to put the first term from the trinomial, which is 2t squared. In the bottom right box, you're going to put the constant term from the trinomial, which is 5. In the other two boxes, it doesn't matter which order, you're going to put the values that we figured out here, followed by a t because they represent the middle term of the trinomial. So 10t and 1t is just t, or you could switch those and have 1t here and 10t here. It won't matter. Next, we're going to decide what the common factor is for each row and column. So I'm going to look at this row and decide what is my common factor here between 2t squared and 10t. The common factor would be 2t, so I write that to the left of the box. Bottom row, t and 5. What's the common factor? Well, there really isn't a common factor, so then we just say it's 1. Then we do the columns. 2t squared and t, what's the common factor? That would be t. I write that above. And last one, 10t and 5. What is the common factor between those two? That would be 5. Now we can write our binomials because they are t plus 5 and 2t plus 1. T plus 5 times 2t plus 1 equals 0. And again, in order for this product to equal 0, one of the binomials has to equal 0. So let's figure out when each of the binomials equals 0. T plus 5 equals 0. Subtract 5. T equals negative 5. And 2t plus 1 equals 0. Subtract 1. We get 2t equals negative 1. Divide by 2. And we get t equals negative 1/2. So t equals negative 5, or t equals negative 1/2. Those are our x-intercepts, our roots, our zeros, our solutions for this quadratic equation. Example, solve x squared minus 3x equals 0. Notice that this one is a binomial. It only has 2 terms instead of 3 terms. For binomials, there's only 2 ways to factor. We can either have a common factor, or it's a difference of squares. Or we could have both a common factor and a difference of squares. But there's only those 2 different things. Common factor, difference of squares. So does this binomial have a common factor? X squared minus 3x. They both have an x in them. So yes, we can factor out an x. And then we're left with x minus 3 equals 0. So x times x minus 3 equals 0. These are our 2 factors. X times the binomial x minus 3. If either of those 2 equals 0, then the product equals 0. So when does x equal 0? Well, x equals 0 when x equals 0. When does x minus 3 equal 0? Add 3 to both sides. And when x equals 3. So x equals 0 and x equals 3 are our 2 solutions. Example, solve 9x squared minus 25 equals 0. Again, we have a binomial. So do we have a common factor? 9x squared and 25. There's no number that divides 9 and also 25, so no, we don't have a common factor. So if this is factorable, it has to be by a difference of squares. Difference means minus, so we have that. It's 2 terms with a minus in between. Then we need to figure out, is this a perfect square and is this a perfect square? The square root of 9 is 3, and the square root of x squared is x. So that's a perfect squared term. The square root of 25 is 5, so that's a perfect squared term. So this is a difference of squares. To factor a difference of squares, you take the square root of the first term, which we said was 3x, the square root of 9 is 3, square root of x squared is x, and the square root of the last term, square root of 25, is 5. And then you write that twice, 3x, 5. Then in one binomial you put a plus, and in one binomial you put a minus. And then that product is equal to 0. So let's write ourselves a little note here. To get the first term of each binomial, we took the square root of 9x squared. And to get the second term of each binomial, we did the square root of 25. Then again, if this product equals 0, then one of the factors has to equal 0. So let's see when this one equals to 0. 3x plus 5 equals 0. Subtract 5. 3x equals negative 5. Divide by 3. X equals negative 5 over 3. And then when is the second factor equal to 0? 3x minus 5 equals 0. Add 5. 3x equals 5. Divide by 3. And we get x equals 5 over 3. So x equals negative 5 over 3. And x equals positive 5 over 3. Those are our 2 solutions, also called roots, zeros, or x-intercepts. Example, solve 2x plus 1 all squared plus 3 times 2x plus 1 minus 28 equals 0. So this looks fairly complex, but notice that we have the same binomial here as we do here. So if we replaced that with some other variable, let's say that we called it t. Let's let t equal 2x plus 1. Then if we rewrite this quadratic with t, we get t squared, because 2x plus 1 is just t, plus 3 times t, again, because 2x plus 1 is t, minus 28 equals 0. Now this looks like a trinomial that we've factored. We don't have any common factors. We have 1, 3, and negative 28. There's no common factors. And because there's a 1 in front of the t squared term, it's a basic trinomial. So we want two numbers that multiply to negative 28 and add to 3. That would be 7 times negative 4 is negative 28, and 7 plus negative 4 is positive 3. Because it's a basic trinomial, we can go right to our two binomials. We have t plus 7 and t minus 4 equals 0. At this point, because remember, we're actually trying to figure out what x equals. And now we have t. So now we want to go back to having x. Remember that t equals 2x plus 1. So down here, where I have a t, I'm going to replace that with 2x plus 1. Then I get 2x plus 1 plus 7 times 2x plus 1 minus 4 equals 0. I could have brackets around the 2x plus 1. In this case, it's not going to make a difference. If my t was here after a minus, then it would definitely make a difference because I would have to multiply the negative into the brackets. But in this situation, the brackets are not going to do anything here. So now I can write it without the brackets. 2x plus 1 plus 7 and 2x plus 1 minus 4. Combine our like terms, we have 1 and 7, and we have 1 and negative 4. So we get 2x plus 8 times 2x, 1 minus 4 is negative 3, so 2x minus 3 equals 0. Now we want to solve for x. If the product equals 0, then one of these factors has to equal 0. So when is 2x plus 8 equal to 0? Subtract 8. 2x equals negative 8. Divide by 2. X equals negative 4. When is 2x minus 3 equal to 0? Add 3 to both sides. 2x equals 3. Divide by 2. X equals 3 over 2, or you could write that as 1.5. So our two solutions, x-intercepts, roots, zeros, are x equals negative 4 and x equals 3 over 2. So let's put some notes here. In this step, we subbed back in 2x plus 1 for t. And then solve for x. A note here, if we want fully factored form, because sometimes a question will just say to fully factor something, and other times it says, what are the solutions? So if it says to fully factor, we're not going to do this part, okay? That's if it says find the x-intercepts, the roots, the zeros, or the solutions. So here, 2x plus 8 times 2x plus 3, that's almost fully factored. But with this complex one, notice that in this binomial, we have 2x plus 8. So there's actually a common factor of 2. So we can factor that out. 2 goes in front of that binomial. We're left with x plus 4. 2x divided by 2 is x. 8 divided by 2 is 4. And then times our other binomial, 2x minus 3. That one does not have a common factor. Equals 0. This would be fully factored form. So keep that in mind. I believe there are some questions on your quiz where it's just asking you to fully factor. So keep that in mind for these questions where you have to substitute in a variable for a binomial that you could end up, once you've factored down to 2 binomials, you could end up with a common factor in one of those that you need to factor out in order to fully factor it. That brings us to the end of Chapter 4, Lesson 2.